Hi, everyone. Welcome to Shuko Math Practice Lab, Learning Through Practicing. And right now we are in the practice set number 4. We are still in this unit, how to use derivative to decide the functions, graphs, shapes like increasing, decreasing, those things. So in this video, we're going to talk about the concave up and the concave down, and also the inflection point. And we're going to use the second derivative to find it. Our practice set number 3, and that's our previous video. You know, we also work on the concave up and concave down. But the practice set number 3 basically is they give you the graph of the function. So sometimes they give you the first derivative graph, and then want you to use the first derivative graph to decide the functions concave up or concave down, and sometimes I give you second derivative graph and then want to use to determine the functions concave up and concave down. And that is pretty, important concept. If you get all that right, I think you got a pretty good ideas. So this practice is very mechanical. So basically, instead of give you the graph, and so they will give you a function, say, hey, f of x is equal to this functions. How do I use the second derivative, to find, to determine is a concave up and the concave down? So it's very, very mechanical. And if you're not good at your derivative formula, you probably want to review it. That's the whole key, whole key things here is, if you can take a good derivative, I think then with a good algebra skill, I think you should have no problem with that. Okay, so these are the 5 problems we're going to practice how to reuse the second derivative to find the concave up, concave down, and inflection point. So I mixed in for different type of the functions, the polynomial, root function, log functions, and even trig functions. Like I said, the key things here is make sure you take the derivative correctly. Then use your algebra skill, try to combine it. I think that's the hardest one, try to combine it, simplify it, all right? So now it's a good place to pause your video and then try to, work these 5 problems by yourself first to see, how many problems you know how to do it or where you get stuck. So when you finish, then come back and resume the video, and then we can work together. Okay, so I'm going to work with you, walk you through these 5 problems here. Okay, so now if you want, you can pause the video, and I'm going to the whiteboard. Okay, so I will talk to you when I get into the whiteboard. Hello, I'm back. Okay, so like I mentioned in the introduction, this video we're going to talk about is how to find the concave up, concave down, and the inflection points here. All right, so let's do a brief review. So we know the concave up, right? So that means is your function go like this, and the concave down is something like go like this. So that's what is called the concave up, right? So this is we call it is up, and this is down here. Okay, so in the previous, video, we say in order to decide f of x is a concave up or concave down, we have 2 ways. We can use the first derivative. So we say if the first derivative f of x, right? If f prime x is increasing, then I know my f of x is a concave what? Concave up. So if my f prime x is decreasing, then I know my f of x is what? Concave down, right? And we practice this, use, from our previous practice set number 3, we had a few graphs, practice this. If you forget, go back to review the video again. Then we can also use the second derivatives here. So the second derivative, we say the f prime x. If f prime x is greater than 0, And then we'll say the f of x is what? Is a concave what? Concave up, right? And the f prime x is less than 0, then we said f of x is what? Is a concave what? Concave down. Okay, so now, of course, you can find it. So like find the point, so how to find the points, right? So how to find the inflection point? Oh, we call it as a potential inflection points, right? Okay, so what you need to do here is you set the f prime x equal to zeros, right? So after you set for the f prime x equal to 0, you solve for x. Okay, and then you also need to see if the f prime x, double prime x, the where, if they have like denominator where it's non-defined, right? So it's not defined. You also want to find what is the, so you find it, what is the x here, we'll give it a f double prime x is not defined. Of course, if this x is here is not in the domain, then I don't worry about it. But sometimes the x will be in the f of x domain, but f double x is not going to be defined. We're going to see one of those problems in our practice set. So after you try to find it, right? So then you put those x here into a number lines here, right? So for example, it's A, B, C, D, and then you put the f double. You try to find the f double prime x to see like it's a positive, negative, negative, positive, something like that. And then you will say, oh, okay, the positive is a concave up, then this is a concave down, and the positive is concave upwards, right? So we know the inflection point is a concavity change, and then you will see, oh, this is where the concavity change, this is where the concavity change, then those points are my inflection points. So the process is very, very mechanical. You take the first derivative, then you take the second derivative. You set the second derivative equal to 0, solve for x. Then you take a look at the second derivative. Is any points there? Second derivative is not defined. You solve for x. Then you plot all the x's in here. Then in here, you put the f double prime x here to see which interval f double prime x is positive or negative, right? And then you can decide it. Then the points where concavity change, that's what we call it is what? Inflection points. Okay, so let's start. We have 5 problems. Let's try to get it done here. Okay, so remember, like I said, it's very, very mechanical. And you need to be good at your derivatives, right? If you're not good at your derivatives, it's a good time to review it. Okay, so first we always, so it's the first derivative, so f prime x. Okay, so f prime x, so here will be the 3x squared minus 12x, all right? Then second derivative, f double prime x, right? So this is 6x what? Minus, see here, I made a mistake. So this is 12, it's not 12x, right? So this will be the 6x. Okay, now I set the second derivative equal to 0. So what I find here, x equal to what? X equal to 0, right? Okay, so when x equal to 0, and the second derivative is 6x, there's no such value, x is non-defined. Okay, so I put the x equal to 0 here, and this is my f double prime x. Now I need to decide it's a negative or positive, right? So because the second derivative is 6x, for anything less than 0, so this of course is 0, negative. For anything greater than 0, it's a positive, right? So after that, then I can decide, because negative is what? It's a concave down. I like to use this notation, and this one is a concave up. So this is my f of function is concavities, right? So now I can come to the conclusion. So the f of x is a concave up. Is from where to where? Is from 0 to infinity. And the f of x is a concave down. So where is the concave down is negative, so it's negative to infinity. And then take a look at x equal to 0. Here is where the concavity changes, right? So now I know the inflection points going to happen at x equal to 0, right? Then the f of 0 will be equal to what? Will be equal to 2. So I know my inflection point is 0 and what is 0 into 2, right? So this one is pretty straightforward. So for the polynomial, I like the polynomial. Polynomial derivative is pretty easy. Okay, now let's take a look at the next ones here. We have the fractions here, right? So the first thing is not a fraction, we have the radical, we have square roots here. Okay, so the first thing is here, you see this is 6 minus x is inside the square roots. So I know the square roots, those special function we have domain restrictions, right? So here, I know the domains here is what? Is x has to be less than or equal to x, right? So when I try to find the inflection point, it cannot be outside the domains here. Okay, after that, now let's just do the, so first things here, we do the f prime x. Okay, so it's x times 6 minus x. So what rule we're using here? Product rules, right? So take the derivative of first one. So x, you take derivative is 1. So this will be 6 minus x. Then plus, you hold the first one, you take the derivative of the second one. So second one is 6 minus x, the square root really is 6 minus x to the what? Half, right? Use the powers rule. Okay, so this one times 1/2, right? You move this one to here. Then this is 6 minus x, 1/2 minus 1, so it's negative 1/2. And then the chain rules here, right? So it's negative 1. That's why I said you need to be very careful when you take the derivative. If you take the derivative correctly, most likely you will get the answers, right? So here now, this is 6 minus x, and then this is minus 2x here, right? And the 6 minus x to the square, so this will become to the bottoms here. Correct? Okay, so now the next thing here, like I say, you need to use your algebra skill, try to combine it, right? So now I have here, because I need to take the second derivative, so I say, okay, now the way I combine, to find the common denominators here, right? So the common denominator is 2, the 6 minus x, and this is 2 square roots of the 6 minus x. Okay, so the first thing here, this is where a lot of students, if your algebra is not strong, so this is the place you're going to make mistakes, right? So this is 6 minus x square roots. Then here's the common denominator. So the top will become to 2, the 6 minus x, right? Because 6 minus x is the power 1. This is 1/2. So 1 minus 1/2, that's why I give you the square roots of 6x. And then these ones here will just be itself, right? Because the denominator. So now I combined here. So this is 2, 6 minus x. There's 12 minus 2x minus x, right? Okay. So this will be 2, the 6 minus x. And then here is what? It's 12 minus 3x, right? So if you like, you can factor the 3 out. So this is 2/3, and this is the 6 minus x, and this is what? 4 minus x, right? Like I said, your algebra skill is super, super important, right? So I can really take this 3/2, right? So here really will become, this is 4 minus x, and the square roots of the 6 minus x is here. So this is my first derivative. Like I say, if you know how to take the derivative, then basically, you just be patient. And when you use the algebra, you need to be careful. Okay, now I'm going to take a look at the second derivatives, right? Okay, second derivative. So this is 3/2. Let's put it in the front so I don't get confused about that. Okay, so 3/2. Now this is quotient rules, right? So quotient rule will tell you what you square the bottom. So 6 minus x square roots, you square that is 6 minus x, right? Okay, then the top, is what? You take the derivative of the top, right? So 4 minus x, well, the derivative is -1. Then you times the bottom, so it's 6 minus x. Then minus, right? Then minus, you hold the top, right? So the top here is what? It's 4 minus x, right? You minus, then you take the derivative about the top, bottoms, right? So bottom is square root of x, 6 minus x, so it's 1/2, right? So this is a 6 minus x to the what? -1/2. Hey, don't forget what? Chain rules here. And so here you need to be very careful. So that's why where, you know, if you're not careful, so that's where the place will kill you, right? When that means you won't be able to, you know, get the correct answers here. So let's just be very careful. How do I combine it, right? So here, this is -6 minus x. Also, I tell my student, do not skip the step. When you skip the step, that's very, very dangerous, right? So here, this is like a negative, right? So I can change it as to plus, all right? So this one's here, and then put this is 6 minus x bottom, and this is 4 minus x, right? So far, so good? All right, so far, so good, right? Okay, so now, one more time, we need to combine, right? So this is 3/2. This one doesn't matter. Okay, so this is, okay, so this is kind of like I do not like the square roots, make the algebra pretty complicated. So on the top here, so what I need to do here, common denominator again, right? So it's 2 of the 6 minus x plus 2 of the 6 minus x. Hey, take a look again. So this is 2, so I have a 2 here. I have a negative here. This is square root of, so what I become 2, 6 minus x, right? Then this one is just itself, so it's 4 minus x here. Okay, so now this is 3/2. And now here, this is 6 minus x. And the top, I can combine it right now. This is 2, the square root of the 6 minus x. So now let's see here. So it's -2 times 12, 6 is -12 plus 2x plus 4 minus what? Minus x here. All right, yeah, okay, good. So far, so good. Okay, so now I need to combine a little more. So this is 3/2. So now I'm going to move this one right to the denominator. So this one will give me, so this is 2. So it's 6x times the square root of the x. So how many I have? So this is 6 minus x, 3/2, right? Okay, so now the top here is -12 plus 4 and 2x minus, so it will be x minus 8. Wow, it's not bad, not bad. We simplify to a pretty decent numbers, right? So here, so this is 3/4. And so this is the 6 minus x to the 3/2. And this is x minus 8. Okay, so like we said, we set the second derivative equal to 0, right? Okay, so let's set the second derivative equal to 0. So the f double prime equal to 0. So we know the f double prime equal to 0s, right? And then the double prime equal to 0 is a fraction, so it has to be top. So that means x minus a equal to 0. If x minus a equal to 0, that means x equal to 8. But x equal to 8, look here, the domains here is x less than 6. So this number cannot be, right? Because it's not in the domain. So x cannot be, you know, at 8. Okay, so the next thing here is we said f prime x not defined. So that means the denominator equal to 0. So where the f prime x not defined, x equal to 6, right? So this is the place, the x equal to 6 probably is the potentials, right? Okay, so now let's take a look here. So what is the So we say, okay, we put this is x equal to 6, right? So when the x is less than 6 is here, right? So what happens here? So this part, this is what? This is negative. Do I need to consider here? No. Why? Yeah, because I don't need to consider here. Why? Because the domain is still the same. So I know these functions, right? So this is my f double prime x, right? So f double prime x, when the x is less than 6, right? So this side is negative. So that means what I have here, I have a concave what? Concave down, right? So this is my original function, concave down, right? So that's why we said, this one's here. So this is a concave down. So the f of x, so this is capital X. So this is capital X. It's a matter. Okay, so this is a capital F for double X, and this is the F double X, right? Okay, so now I know that, so the no here. So this is capital F of X. Okay. So this is a capital F of X. So I know the F of X is a concave down, right, from the negative infinity to 6. And because it's always concave down, so it's no inflection point. Did you get it? Okay, so this one is very kind of complicated. Is complicated because of algebra, but like I say, it's very, very mechanical practice. So you take the first derivative, second derivative. So just be very careful when you combine, okay? Now let's take a look at the next ones here. So this one hopefully will be a little easier. So first one, so let's take a look at f prime x. So natural log, everybody still remember? Okay, so natural log will be x squared plus 9. Then don't forget what? Chain rule, right? Chain rule. Okay, now let's take a look at f double prime x here. Okay, f double prime x here, so it's a quotient rule. So square the bottom, so this is x squared plus 9. Use square. Then take the derivative about the top, so it's 2. Then hold the bottom, x squared plus 9. Minus, you hold the top, then you take the derivative of the bottom. Bottom is x squared plus 9, so it's 2x. Wow, this one is pretty easy here. So this is x squared plus 9. The algebra part is not too bad. So this is 2x squared plus 18 minus 4x squared. Okay, so here it will give you x squared plus 9 to the square. Hey, this is 18 minus 2x squared. Well, it's good. So this is x squared plus 9 squared, so it's 2. This is 9 minus x squared, right? Okay, so now I set, the f double prime x equal to 0. Every time you have a fraction, the zeros here, that means the top equal to be 0. That means 9 minus x squared equal to 0. So x equal to 3 and x equal to negative 3, right? And both will work because the domains here, because here this is x squared and this is 9, so the domain is always it's positive. So the x for any numbers, right? So domains here is the all real number because this is a square, it will work. Okay, so then we also say where the f double prime x is not defined, right? So let's see, do we have a f double prime x not defined? Well, I don't, because the denominator, even I have a denominator, but the denominator is x squared plus 9. So every number is, you won't get zeros, right? So now I know I only have a negative 3 and the 3 is here, right? So now I put the f double prime x here. Okay, so the f double prime x here. So this is 2, the 9 minus x squared and x squared plus 9. Right? So now when the x is less than -3, but you squared it. So 9 minus like 4 square, so it's negative. So here, f double prime will be negative. Okay, now the middle intervals here, choose any points. I say, okay, let's try 0. 9 minus 0 square is a positive, so this is a positive, right? And then for anything greater than 3, so the same thing, you choose 4, 9 minus 4 square become negative again. Okay, so now here, the bottom one, I will going to put what? F of x, right? So this one is negative, is a concave down. This is a concave up, and this is a concave down here, right? Okay, so now I can do here, so I will say, okay, so f of x is a concave up from where to where? -3 to 3, right? And the f of x is concave down where? -infinity to -3 and the 3 to the infinities, right? And then you see here, oh, here is the concavity changes, right? So here is the 2 points of the concavity change. So my inflection points, right? So there could be x equal to -3 and the x equal to 3, right? So when the x equal to 3, -3, f of -3 is what? It's a natural log 3 to the square is 9. 9 plus 9 is 18. And here, this is f of the 3 is the same thing. It's a natural log 18. So I have a true inflection point, -3 and then natural log 18 or +3 natural log 18, right? So this one is pretty, I think it's the derivative is easy, right? So it's easy to do. So, you know, not much the algebra, you know, you need to deal with. So it's pretty good. Okay, so now let's take a look. Next one here is the trig functions, right? So they give us the ranges here. That's the domain. So that's good. Let's see. I like trig function. Trig function typical the derivative is not too complicated. Okay, so the first derivative, x is 1 minus the sine, derivative is a cosine, right? Okay, so now I like this, is easy. So double derivative, 1 is a constant, negative cosine is what? It's a sine x, right? Okay, so now you set the second derivative equal to 0. That means sine x equal to 0. When the x equal to the, from the pi to the, oh, so it's here, oh, I'm sorry, here is 4 pi. Okay, so here is 4 pi. Okay, okay, so the 4 pi, so x will be equal to the 0, pi, 2 pi, 3 pi, and the 4 pi, right? Okay, so now I'm going to do the same way like we did before. So this is 0, pi, 2 pi, 3 pi, and the 4 pi's, right? So this is my second derivative. So this is the second derivative is double x here is sine x, right? Okay, so now let's take a look. Sine x, so here, this is the graph of the sine x, right? So this is 2 pi, this is 4 pi, right? Okay, so now I know from 0 to pi is what? It's positive, right? From the pi to 2 pi is negative. 2 pi to 3 pi is positive. 3 pi to 4 pi is negative. So then that's why my function s of x, this is concave up, concave down, concave up, and the concave down, right? Very good. And then I have this one could be this is my inflection point because of concavity change. This one will be my inflection point, and this one will be my inflection points, right? Okay, so now let's write it. So I know s of x is a concave up So it's from 0 to pi, and the 3 pi to what? 4 pi, right? And the S of x concave down. So what is concave down? See here. Oh, I see here. I did not pay attention. So here is the concave up. So here should be the 2 pi to 3 pi. Concave down is pi to 2 pi and 3 pi to 4 pi, right? Okay, so that's good. Then my inflection points will be x equal to pi, right? So the s pi is equal to what? Is equal to pi. Then x need to be equal to 2 pi, be my another fraction point. So the s2 pi is equal to 2 pi, and the x equal to 3 pi. This is my another fraction point, right? So this is 3 pi. So you plug into the original function, this will be 3 pi. So here I have 3 inflection points here. Okay, so those 3 points will be pi pi, 2 pi, 2 pi, and 3 pi, 3 pi, right? Okay, so this one is not bad. This one, the algebra part is also pretty easy. Okay, let's take a look at our last one. This is our finale. And this one, every time I have those type of the kind of the roots, right? This is cube roots. Those roots really require you to be very careful and when you do the algebra combination, right? Okay, so now let's start here. First derivative, always the first derivative. Okay, so let's do a power rule. So this is 5 times move the 2/3 down, right? So this is x. So what happened to the top? 2/3 minus 1 will give you what? Negative 1/3, right? Okay, then minus 2. Move the 5/3 down. Then the x 5/3 minus 1 is what? 2/3, right? Okay. So here's so this is 5 times 2 is 10 over 3. So I can take the 10 over 3 out, right? Take all the constants out, simplify. So now when I take all the constants out, the first ones here, this will become x to the what? 1/3. Okay, and the minus, this is x to the 2/3. Okay, common denominator, combine. So this is a 10/3. So this is x to the 1/3 minus x to the 1/3, common denominators, right? So, okay, take a look. This is a 2/3. If you put the 1/3 on the denominator, so here will be what? Will be x here, right? So this one's here. So this is where a lot of students make a mistake because they don't know after you find a common denominator with fraction and exponents, right? So that's why you need to be careful. So here, after you combine it, it's not too bad. So this is x 1/3. This is 1 minus x. Not bad at all. All right. Now let's take a look at the second derivatives, right? So second derivative. Okay, so second derivative, leave the constants. Okay. Now, just like we did before, one more time, square the bottoms, right? So 1/3 is square is 2/3. Okay, now check the derivative on the top, right? So the top is here, right? Top is 1 minus x. So when you take the derivative, it's -1, right? So it's -1 times you hold the bottom, so it's 1/3, right? Okay, then you minus, you hold the top, so it's 1 minus x. You take the derivative of the what? You take the derivative of the bottoms, right? So the is 1/3, so this is 1/3, right? And then the x to the what? X to the negative 1/3 minus 1, negative 2/3. Okay, all right. So now here is where, so this is 10 over 3. So let's be careful. So this is x to the 2/3, right? Okay, so this is negative x to 1/3. Okay, now I FOILed it, right? So I FOILed it, so this is negative 1/3 x to the negative 2/3. Then negative is positive, right? So this will be equal to plus, right? So this will be plus 1x times 1/3 and the x to the negative 2/3, right? Okay, so basically what I did here, I just FOIL, like the kind of here, FOIL that out and be careful about the negative signs here. Whew. Wow. Okay, now, okay, so now let's try to combine this. All right, so let's try to combine this here. So let's see how do we combine it. Okay. Okay. So now here, this is 10/3, right? So this is x. Okay, so this is x to the 2/3, right? Okay, so here the denominator is negative. So maybe I should just don't skip the step. If I skip the step, you might not know that. So this is 1/3, right? So this is 1/x 2/3. And the plus 3 of the x. Then here, this is x to the 2/3. All right, just be very careful, step by step, be patient, and you will get it, all right? Okay, so then this is 10/3. The bottom still is x to the 2/3. Now the common denominator, so common denominator is x to the 2/3, right? Okay, so this is 1/3. Okay, so this is once here is x to the 2/3. And this one's here is 3, the x to the 2/3. Okay, so now that's kind of like, okay, so this one's here, right? So let's put this is 3 to the x to the 3/3. Okay, so now take a look here. What do you need to put here? Okay, so for the first terms here, right? So for the first term, this is 1/3, right? Now you have x 2/3 on the bottoms, right? So what happened here, this will be negative 3x, correct? Okay, and then this one's here is plus, this is 3, and so this is over what? This is over x here. Yeah, okay, so now you can combine it. So now I can move, right? I can move all the denominator. So here, this is the denominator to the bottoms, right? So okay, I can move that. So this will be 3x to the what? 4/3, right? So the top here, it will just simplify, be 3x minus 1 plus what? Plus x. Oh boy, that's really pretty nice form, right? So this is 3, the x to the 4/3. So now you can take the negative 1 out, it will be 2x plus 1. Ta-da, we got it. Oh my gosh, right? So now I will say now I can find the potential place. So I said f double prime x equal to 0. Okay, so now it's easy. So if this is a fraction, so which point is equal to 0? Numerator, right? So 2x plus 1 equal to 0. So x equal to the negative 1/2. That's right. Then we also say, hey, where is f double prime x is not defined. Okay. So here you take a look, you say, hey, because I have a denominator, so I know this number cannot be equal to 0, right? So that means x equal to 0 is not defined. And both this is in the domain, because this functions here, domain is cube roots, right? So I can have negatives there. So that's good. And so now let's see here. So we can graph it again. So this is negative 1/2, and this is 0. So here you put in your f double prime here, right, to determine the positive and negatives, right? Okay, so now let's take a look. is less than negative 1/2. Let's say negative 1, right? So it's negative, negative. Then you have a negative sign here, is positive. So this is what? Positive. Then between the negative 1/2 and 0, let's take a look, it's negative 1/4. Then this is a positive, positive and negatives, right? So this is negative. Greater than 1, so let's see here, greater than 1, let's say 3. So 3 times 2 is 6, so it's negative. So it's negative. All right. So now let's take a look at the, here I put my f of x for concavities, right? So I know this is a concave up, concave down, and concave what? Concave down, right? So now I can write it. I said f of x is a concave up. From where to where? From the negative infinity to negative 1/2. And the f of x concave down, because the 0 is, is inside the domains here. So g function, it is, it is continuous at 0. So I would say, then this one here is a concave down in the negative 1/2 to what? To the infinity. Oh, here I should use I have the capital GX here, so I need to better have the match my notation, or you guys going to get confused where the f of x come from. So it's really is g double prime here. I just so used to the f of x. So here you put this is g double prime x, and in here instead of f of x, now this is gx here. Okay, so now here this is gx. Now I fix it. Okay, that's good. Okay, so gx and gx is a concave down, right? So in here you don't need to write the negative 1/2 to 0 and 0 to infinity, because the zeros in here is continuous here. So I don't need to break it into the two different, the intervals here. Then the only where the inflection point is only x equal to the 1/2 is the inflection points, right? It's because the concavity changes here. So I know the inflection point is x equal to negative 1/2. Then you put the g negative 1/2 to the g function to see what you have. So I got this is 6 and 4 to the cube roots here. Okay, so I know my inflection points will be negative 1/2 and 6 cube roots of the 3. All right. All right. So this one's here, like I mentioned before, is very, very mechanical, right? So how do I find the concavities here? Remember, you take the first derivative, you take the second derivative, and then set the second derivative equal to 0, solve for x, right? So here, okay, so if let's go back to the steps, we did so many problems here, right? So here, so what do you do here? You find the first derivative, you find the second, you find the first derivative, you find the second derivative, right? And then, so you set the second derivative, right? So in here, you set the second derivative equal to 0, you solve for x. Then you also take a look at where is the second derivative is not defined, you solve for x. Then you mark it, right? After you mark it, then you use the second derivative to decide what is the positive or negative. And then this will determine your function f of x is concave up or concave down here. Like I say, it's very, very mechanical. It's really tests your derivative skill and also your algebra skill. Especially we did 2 problems. So the algebra combination is kind of like tedious. But if you just be patient and don't skip the step, and I think you will get it. And most of the common problem the student get is negative sign, screw up a negative sign, or miss a constants, those things. So just be very careful about your algebra. All right, that's it for this videos here. And I hope you like it. If you like it, feel free to subscribe it. And if you're still confused, you can leave me a comment, and I will, and I will help you to understand this. Okay, it's so nice to talk to you, and I guess we will, I'm looking forward to talk to you in our next videos here. All right. So bye, and you have a good day here. Okay. Bye bye.